Hi everyone, in this video we're looking at surface area of basic 3D shapes. By the end of the lesson you should be able to solve problems involving prisms, cones, spheres and cylinders. So the four basic 3D shapes. To be successful you need to select the appropriate formula, substitute the values correctly and then calculate appropriately and report back in the appropriate units. So again, looking at the QCAA formulas that are provided to you, you've got the surface area of a cylinder, cone and a sphere. So it's your job to remember what those variables are. So what does R represent? H and S and pi. So where we're looking at with those shapes. So to find the area of a basic shape, or a basic 3D shape, first of all, it helps sometimes maybe to draw a net. So when you draw a net, you're actually going to create like all the surfaces for your 3D shape. So for example, if I have a rectangular prism, I can open that up and lay it flat, and I will see that there are going to be 1, 2, 3, 4 rectangles and 2 smaller rectangles if they are all squares. So my shape is made up of 6 different areas. Now there is like a general formula for that, but that is not what we're looking at in this video. We are looking at cylinders, cones and spheres in this one. So looking at the cylinder here, we actually opened it up. It would be 2 circles, which I've just done really poorly there, and the curved surface of our cylinder, which actually, if you were to open it up, is like a rectangle. So this circle is going to have, its area formula is pi r squared, and there's 2 of them because they're identical. So surface area equals 2 pi r squared plus this length of this rectangle is going to be the circumference from this circle, and to find the circumference of a circle is 2 pi r, and multiply that by the height of your rectangle and you've got the area for it. So it's going to be 2 pi r h. I substitute the appropriate values in. Now I've made a bit of a I've missed that bit of detail. You'll see that these are actually in 2 different units, so you'll have to convert one to the other. So I'm just going to convert to centimeters. I just feel a bit more comfortable with that. So I'm going to substitute in 2 pi which is 50 plus 2 pi 50 times 150, because I've converted that to 150 centimeters. Be mindful, sometimes you might get given a diameter, so it'll be your job to take the diameter and divide it by 2 to find the radius. So just pay attention to those minor details. So our surface area, once we plug that into our calculator, is going to give us 62,831.85 centimeters squared, because we're dealing with surface area. Now if you're going to put that into meters squared, you need to be mindful of, when we talk about a linear line, there are 100 centimeters in 1 meter. If you divide this number by 100, you're not going to get meters squared. Now if we have a look at a square and it was a 100 centimeters by 100 centimeters, that is going to give us 1, 2, 3, 4, 1, 2, 3, 4 centimeters squared, and that is the same as 1 meter squared. So we actually need to move our decimal place 1, 2, 3, 4 spaces, which gives us surface area equals 6.28 meters squared. So having a look at, I've just got a triangular prism in here, and I just want to quickly mention to you is recognize what's going on with a triangular prism. If you have, in this case it's kind of easy but not, you've got 3 rectangles and they're actually going to have all the same length. And because this is an equilateral triangle, they're actually going to have all the same widths. So that would be surface area equals 3LW. Now, depending on what type of triangle, you might actually have to have 3 different lengths and widths. If it was a scalene, if it was an isosceles, you might have 2LW plus like A, A times B. And then in this case here, we've got 2 triangles, so it's going to be 2 height divided by 2. You actually need Pythagoras' theorem to find the height of your triangle because it's an equilateral. It's not a like right angle triangle where you can already see the height. So you would do your Pythag first and then substitute that in for your height. So that's a formula that you could use to find this triangular prism. But we are going to look at the cone here. So our formula is surface area equals pi times r, which is the radius, s. Now s is the slope of the cone component here. So this one here is a pretty straightforward from this shape, plus pi r squared. Now pi r squared is the circle that we have here. That's where that part of the formula comes from. And the pi rs is to do with, because this is a sector of your circle that would be like your curved surface that would go around and make your cone shape. So that's the reason why we have pi r, gives us that one, and the s is the slant. So there is a mathematical proof behind this, but at the end of the day, you just need to know where s comes from. In class, we'll look at what happens when you don't have s though. Okay, so in order to do that, we're going to do FSA, so surface area equals, so you should have like a SA here, or something to denote the difference. Pi times r, r is 12 times 15, plus pi 15 squared. Surface area is going to be, so our answer is 1017.876. I'm just going to go to 2 decimal places, so 0.88 centimeters squared. It's just a matter of putting the appropriate values in your calculator. Sorry, I did fix this. It had 15 there before. I just brain fart. So just editing that there. So looking at a sphere. So the formula for a sphere is surface area equals 4 pi r squared. And how that kind of comes about is that there's pi r squared, that's like one circle area, and I think they've picked a number, and they've done probably enough times where they've like found out that it's about 4 circle surfaces of the same radius. So s equals, substituting that in, 4 pi, radius is 7 squared, which then gives us a surface area of 615.75. I'm just going to go to 2 decimal places here, or round to 2 decimal places, squared. So that those are your basic 3D shapes that are probably new to you, as building on from year 9. So cylinder, which is a type of prism, cone and sphere, which are new this year. So you have your homework sheets in the homework tab of OneNote. Okay, thanks guys, bye.